Alright, welcome to chapter 5 in the book. Really making a lot of progress on this. And so far it's been pretty good, better than just reading the BGP RFC. I got to a section that was why can't I? Oh, here we go. I got to a section that was just way too dry. So I'm moving on to this instead, and so far it's been pretty good. Last chapter we learned about more about how to monitor and stress test a server. We learned about the difference between measuring the number of operations per second versus the result of the operations per second. And then we learned some special tools. I did make some highlights. When I do code, I generally don't do debugging, so I highlighted Pdb Debugger because I want to kind of get. There have been points where, and let me be clear, I do debugging when I code, but I use print statements. So another thing you could do is use Pdb, and then you can set your code to run, and then stop at a certain way, and you can see what all the variables in the code filled up with, which is basically all I'm trying to do with print statements anyway. So you can do that in a more convenient way. The other thing I saved is importing a CSV and then saving it to a JSON output. Yep, so I actually made a lot of saves. Oh, and I saved learning where the file path is to a module just by printing out the module. I didn't know you could do that before. Yep, and saving timestamps. I saved a lot from this chapter. But let's move on to the next chapter, chapter 5, package management. Often small scripts grow in usefulness and importance, which creates a need to share and distribute their contents. Python libraries, as well as other code projects, require packaging. Without packaging, distributing code becomes problematic and brittle. Once past the proof of concept stage, it is helpful to keep track of changes, advertise the type of change, for example, when introducing a backward incompatible update, and provide a way for users to depend on a specific version. Even in the most straightforward use cases, it is beneficial to follow a few packaging guidelines. This, at the very least, should mean keeping track of a changelog and determining a version. There are several strategies to follow for package management, and knowing a few of the ones most commonly used allows you to adopt the best option to solve a problem. For example, it might be easier to distribute a Python library through the Python package index, PyPy, instead of making it a system package like Debian and RPM. If a Python script needs to run at specific intervals, or if it is a long-running process, then system packaging working together with systemd might work better. Although systemd is not a packaging tool, it does play well on systems that depend on it to manage processes and the server startup sequence. Learning how to handle processes with a few systemd configuration settings and some packaging is a great way to increase the capabilities of a Python project further. So I'm going to pull up my lab here and see if I have systemd installed on a VM that I've been using for this book. Okay, it'll take a little bit of time to load, so we'll keep on reading while it's loading. The native Python packaging tools have a public hosting instance for packages, PyPy. However, for Debian and RPM packages, it requires some effort to provide a local repository. This chapter covers a few tools that make it easier to create and manage a package repository, including a local alternative to PyPy. Having a good understanding of the different packaging strategies and healthy practices like proper versioning and keeping a changelog provide a stable, consistent experience when distributing software. No, I do not want a newer version because that means I've got to update my server as well. And I have not had good experiences doing that. Although I was using ESXi instead of KVM at that time, so maybe it'd be easier to do that. But if I upgrade this, I definitely want to upgrade it on the server first before the client, because it's easy to upgrade the client. The server's where it's challenging. So if that goes smooth and easy, then I will update the client. Okay, I think I read this. Yeah, having a good understanding of the different packaging strategies and healthy practices like proper versioning and keeping a changelog provide a stable, consistent experience when distributing software. Okay, so why is packaging important? Several factors make packaging software an essential feature of a project regardless of size. And before we learn about those features, I want to see if I gotta wait for NetMeet Code to install it. Keeping track of versions and changes via a changelog is an excellent way to provide some insight into new features and bug fixes. Versioning allows others to determine better what might work within a project. When trying to identify issues and bugs, a changelog with an accurate description of changes is an invaluable tool to help identify potential causes of system breakage. It takes discipline and hard work to version a project, describe changes in a changelog, and provide a way for users to install and use a project. However, the benefits when distributing, debugging, upgrading, or even uninstalling are significant. Okay, so let's see if we have systemd. Don't have it, assuming that was the command. Yeah, it is. Okay, so I guess I'll get systemd since I don't have it. I probably need to do an update. Okay, so when packaging might not be needed. Sometimes you don't need to distribute a project to other systems at all. Ansible playbooks are usually run from one server to manage other systems in the network. In cases like Ansible, it might be enough to follow versioning and keep a changelog. Version control systems like Git make this easy with the use of tags. Tagging in Git would still be useful if a project does not need to get packaged, since most tooling can consume the tag as long as a tag represents a version to produce a package. Recently, there was a long debug session to determine why an installer for a large software project had stopped working. Suddenly, all the functional tests for a small Python tool that depended on the installer completing its deployment were failing. The installer did have versions and kept those versions synchronized with version control, but there was no changelog whatsoever that would have explained the recent changes that were going to break an existing API. To find the issue, we had to go through all the recent commits to determine what could be the problem. Going through a few commits shouldn't be difficult, but trying to do so on a project with more than 4,000, try doing so on a project with more than 4,000 commits. After finding the cause, 2 tickets were opened, one that explained the bug and another one to ask for a changelog. Okay, so the next section is packaging guidelines. Before packaging, a few things are worth considering so that the process is as smooth as possible. Even when you don't plan to package a product, these guidelines help to improve a package overall. Projects in version control are always ready to be packaged. Before we get to the guidelines, let's see what the systemd command does. The system has not been booted with systemd, so if there's an example, we'll do it, but for now, I'm just going to keep on going. So here's a guideline to help improve a project. The first guideline is descriptive versioning. There are many ways to version software, but it is a good idea to follow a well-known schema. The Python Developer's Guide has a clear definition of acceptable forms of versioning. Okay, and I'm definitely gonna highlight this because I'll need to go back to this. The versioning schema is meant to be extremely flexible while keeping an eye on consistency so that installer tooling can make sense and prioritize accordingly. For example, a stable version over a beta one. In its purest form, the most commonly in Python packages, the following two variants are used: major.minor or major.minor.micro. Valid versions would then look like, although there are many variations described by the excellent Python Developer's Guide, concentrate on the simpler forms listed above. They are good enough to produce packages while adhering to most guidelines for both system and native Python packages. A commonly accepted format for releases is major.minor.micro, and also used by the semantic versioning scheme. Major for backward incompatible changes. Minor adds features that are also backward incompatible. Micro adds backward... Oh! Okay, I read that wrong. So if it's backward incompatible, it's going to be a major release. If it's a feature, but it does not break backward compatibility, it is also, the feature is backward compatible, then it's a minor release. A micro release adds backward compatible bug fixes. So it's not a feature, it's just an update to a previously introduced feature, is a micro. Following the listed versions above, you can deduce that a dependency on an application with version 1.0.0 might break with version 2.0.0. Once the decision for a release occurs, then it is easy to determine the version number. Assuming the current release version of the project under development is 1.0.0, it means the following outcomes are possible. If the release has backward incompatible changes, the version is 2.0.0. Yep, and that's what it said there. Yeah, so, yep, if the release has added features that do not break compatibility, the version is 1.0.0, and we're assuming that the current versioning is 1.0.0, and a new release increments that version number depending on the type of release. If the release is not backward compatible, then the first number gets incremented and the version is 2.0.0. If the release introduces a new feature, but that feature is still does not break backwards compatibility, then the second number is incremented and the version is 1.1.0. The first number is not incremented. If the release is to fix issues that do not break compatibility, the version is 1.0.1. Once a schema is being followed, then a release process is immediately descriptive. Although it would be nice for all software to follow a similar pattern, some projects have a completely different schema of their own. For example, the Ceph project uses the following: major, and then for the and then it doesn't have a micro field. It has a major field, it has a thus far undescribed field with some numbers in it, and then it has the minor field, but it doesn't have a micro field. Major indicates a major release, while not necessarily breaking backward compatibility. So a major, it looks like they blend the major and the minor semantic versioning scheme definitions into major. So major can be something that breaks backward capability, or it can be something that maintains backward compatibility. It just is talking about a major feature that was released regardless of backward compatibility. 0, 1, or 2 mean in order: development release, release candidate, or stable version. Minor is used only for bug fixes and never for features. That schema would mean that 14.0.0 is a development release, while 14.2.1 is a bug fix release for the stable version of the major release. 14 in this case. Yeah, that's a bit tricky to me. I prefer the semantic versioning scheme. Major.minor. Oh, well, patch. They said micro in the book. The change log. As we have mentioned already, it is important to keep track of releases and what they mean in the context of a version number. Keeping a changelog is not that difficult once a versioning schema is chosen. Although it can be a single file, large projects tend to break it down into smaller files in a directory. Best practice is using a simple format that is descriptive and easy to maintain. The following example is an actual portion of a changelog file in a production Python tool. So we can see this is version 1, so it's the original version. Does not say anything about backwards compatibility because there is no backwards version. But we do see that they pushed a new feature to it that didn't change that backwards compatibility. So whether you have feature 0 or feature 1, you can still run it. And then they had to make 3 bug fixes. Try a few different executables, not only Python, to check for a working one in order of preference, starting with Python 3, but ultimately failing back to the connection interpreter. So that looks like it's output from the changelog file that they're using in this example. The example provides 4 essential pieces of information. Number 1, the latest version number released. Number 2, whether the latest release is backward compatible. Number 3, the release date of the last version. Number 4, changes included in the release. The file doesn't need to be of a specific format as long as it is consistent and informative. A proper changelog can provide several pieces of information with little effort. It is tempting to try and automate the task of writing a changelog with every release, but we would advise against a fully automated process. Nothing beats a well-written, thoughtful entry about a bug fix or a feature added. A poorly automated changelog is one that uses all the version control commits included in the release. This is not a good practice since you can get the same information by listing the commits. So I wish they would talk more about that, because I guess I'm just not clear what they want you to put in a changelog that you would not put in a commit, and I don't see that explained. So unfortunately, that's going to be a kind of an unanswered question going forth. Maybe the answer will come up shortly. Choosing a strategy. Understanding the type of distribution needed and what infrastructure services are available helps determine what type of packaging to use. Pure Python libraries that extend functionality for other Python projects are suitable as a native Python package hosted on the Python package index, PYPI, or a local index. Standalone scripts and long-running processes are good candidates for system packages like RPM or Debian, but ultimately it depends on what type of systems are available and if it is at all possible to host and manage a repository. In the case of long-running processes, the packaging can have rules to configure a systemd unit that makes it available as a controllable process. Systemd allows for the graceful handling of start, stop, or restart operations. These are things that aren't possible with native Python packaging. In general, the more a script or process needs to interact with the system, the better it is suited to a system package or a container. When writing a Python-only script, conventional Python packaging is the right choice. Note, there aren't hard requirements on what strategy to use. It depends. Pick the best environment available for distribution. RPM if servers are CentOS, for example. Different types of packaging are not mutually exclusive. One project can offer multiple packaging formats at the same time. Packaging solutions. In this section, the details on how to create a package and host it are covered. To simplify the code examples, assume a small Python project called Hello World with the following structure. The project has a top-level directory called Hello World and a subdirectory Hello_World instead of dash with 2 files in it. Depending on the packaging choice, different files are needed to create a package. Okay, so I think I'm gonna follow along with that. Let's make that directory with those files in here. So, okay, so we're gonna do make directory hello with a dash, and we'll change directory into it. Make another directory with an underscore, change directory into that, and then we'll make 2 files. And we won't put anything in them for now. Okay. By far, the simplest solution is using the native Python packaging tooling and hosting via PyPy. Like the rest of the other packaging strategies, the project requires some files used by setup tools. And I don't have setup tools, so I'm gonna see if I can get that. Okay, so I think it's a Python thing. Maybe they'll tell us how to get it. One easy way to source a virtual environment is to create a bash or ZSH alias that both CDs into the directory and sources the environment, like this. So let's try this. Alias sugar equals source. Sugar in debates. Source. Okay. Oh, I see. Okay, I get what they're saying here. So yeah, I'm gonna save this too, because we can see what they're doing here. So like, for example, I've got this yeah, I've got this Python for DevOps here. So I can make an alias by doing alias DevOps equals source Python for DevOps VNV bin activate and cd Python for DevOps. Okay, so now I've got an alias. Let's say I'm poking around, I'm doing whatever. So I'm in user bin, doing something, looking around, and now I want to go back to my project. I can just do my alias, which I named DevOps, and I'm not only back in my project, I've got the virtual environment enabled as well. Really, really good alias to use. It's keep you from getting lost and have to waste time with extra commands, only to end up in the wrong spot anyway and having to troubleshoot why things aren't working, only to realize you're in the wrong directory. To continue, create a new virtual environment and then activate. Okay, I don't know which directory they want me to be in when I do this. I guess it's said to assume. Okay, so do they want me in this directory? I don't know which directory they want me to be in when I create this. Oh, you know what? They're creating this in a absolute path instead of relative path, so I don't need to worry about what directory I'm in, because it's going to create a virtual environment that is not relative to the directory I'm in. It's in an absolute path that is specified. Okay. Oh yeah, I like this better. You put your, like, I don't like putting your VNV in the directory you're working in. It doesn't make sense to me. Okay, so note setup tools. And you can see here in our parentheses we have packaging instead of VNV. That's just because I named the virtual environment packaging instead of VNV. Setup tools is a requirement to produce a native Python package. It is a collection of tools and helpers to create and distribute Python packages. Once the virtual environment is active, the following dependencies exist. Setup tools, a set of utilities for packaging. Twine, a tool for registering and uploading packages. Install them by running the following command. Perfect. Note, a very easy way to figure out what is installed is to use IPython and this snippet to list all of the Python packages as a Python data structure. Ooh, I like that. That's better than, because I'll show you what, I've showed this many times before, but this is what I would normally do to get modules. But I'm in this special help menu, so I don't have like the power of Python to help with that. So this is a much better way. Yeah, and now I have the power of Python, so I can do test equals this, and then for I in test, print I. And I can get it formatted. Oh, what happened? Oh, did it? Okay. But I can print them out. Oh, I see, okay. Let's see here. Test2 equals type test2. Oh, it's a string. Let's see here. So test3 equals list test2 type test3. test3. Test3 is going to be a list, of course. Print test3. Oh, that didn't work. Yeah, shoot, I thought you know what I can probably do? Test2. So test4 equals this. Test4 dot test2. Ah, that didn't work either. God damn it. Okay, well, whatever. Maybe I you know what? I'm not even gonna bookmark that because that's not working for me. And you can just do a pip freeze. Yeah, like I don't understand why they would want to. I guess maybe if you're, but oh, okay. All right. Well, I'm not going to save that. Package files. To produce the native Python package, we have to add a few files. To keep things simple, focus on the minimum amount of files needed to produce the package. The file that describes the package to setup tools is named setup.py. It exists at the top level directory. For the example project, this is how that file looks. So yeah, we're going to name it setup.py, and it's going to exist at the top level directory of the project, and the project is hello world. So let's do a nano and then setup.py. And from setup tools, import setup, find packages. Okay, and then I don't know. So it looks like on another line they want to use this sort of syntax. I'm not familiar with that sort of syntax in Python. But I guess we're going to try it anyway. Yeah, I'm only familiar with the syntax where there's the word def in front of it. I don't know if this is calling a function or what this is, but I've never seen this before. So we're going to see if it works. Okay, the setup.py file will import two helpers from the setup module, setup and find packages. The setup function, skeptical. Okay, if this is meant to be a function, then you should have the def keyword there, and you should have a colon at the end here, and then something in the function that uses those parameters. But the setup function is what requires the rich description about the package. The find packages function is a utility to automatically detect where the Python files are. Additionally, the file imports classifiers that describe certain aspects of the package, such as the license, operating systems supported, and Python versions. These classifiers are called trove classifiers, and the Python package index has a detailed description of other classifiers available. Detailed descriptions make a package get discovered when uploaded to PyPy, and with just the addition of this one file, we can already produce a package, in this case a source distribution package. Without a readme file, a warning appears when running the commands. To prevent this, add an empty line in the top level directory with the command touch readme. So we're going to save this file, and then we're going to add readme file. To list the project directory should look like this. Oh, you know what? Let's get tree. There we go. So mine's in a different order than theirs, but let's do this. Let's do back. We'll do tree, hello world. There we go. And now we get it more clear. Mine's in a different order than theirs, but that's fine, I think. To produce the source distribution from it, run the following command. So I've got to go back into my... See, this is annoying too, because they say, in order to get this output, you can't be in the package. So if they want you to run this command while being in the hello-world folder, they're misleading you by showing that. Perfect. The output should look similar to the following. It did. It looked very similar to the following. At the top level directory of the project, a new directory called dist is there. It contains the source distribution, a file hello-world-0.0.1.tar.gz. If we check the contents of the directory, it has changed once again. Okay, so now we've got this dist with our actual distribution of the software, and we've got egg info as well. The newly created tar.gz file is an installable package. This package can now be uploaded to PyPy for others to install directly from it. By following the version schema, it allows installers to ask for a specific version, 0.0.1 in this case, and the extra metadata passed into the setup function enables other tools to discover it and show information about it, such as the author, description, and version. The Python installer tool pip can be used to install the tar.gz file directory. To try it out, use the path to the file as an argument. Oh, and I gotta change back into here. Okay, there we go. So one gripe I have is when things in code, like you're getting a handle of it, you understand the syntax, you know, are finally starting to get a hang of how to code, and then something like this happens where in this setup.py file we have a function, apparently, they keep calling it a function, that doesn't have def, that doesn't have a colon, that doesn't have anything that actually uses these parameters defined in the function. It's like, how is that a function? Like, what is that? I've never seen that before. Oh, I see. Never mind. No, this is, okay, it makes sense to me now. Because from setup tools, import setup. So setup is a function, but we didn't define, this code here is not defining the function. That's where I got confused. I thought we were defining a function in this file, but we're calling a function that has already been defined in the setup tools library. We imported it in, and then we called the function and fed it variables. So makes sense to me now. I have no gripes. The Python installer tool pip can be used to install directly. Yep, we did that already. Okay. Yep, and that's the same thing I got up here. Perfect. The Python package index. The Python package index, PyPI, is a repository of Python software that allows users to host Python packages and also install from it. It is maintained by and for the community with the help of sponsors and donations as part of the Python Software Foundation. Note, this section requires registration for the test instance of PyPI. Make sure you have an account already or register online. You need your username and password for the account to upload packages. So I'm going to do that. It might come in handy later to have that account. So I'll do that on my second screen, just in case password shows or anything. Oh, I'm getting tired. Oh, username is invalid. Oh, username, okay. Thought that was, okay. Excellent. Okay, so now I've got that, so I just got to verify my email. Okay, my email is now verified. Okay, so in the sample setup.py file, an example email address contains a placeholder. If the package is going to get published to the index, this needs to be updated to reflect the same email address that owns the Python project at PyPI. Update any other fields like the author, URL, and description to more accurately reflect the project being built. I should have used my Graham's Networking Lessons account for this. That was dumb. That was really dumb. Why didn't I do that? To make sure things work correctly and to avoid pushing to production, the package is tested by uploading it to the test instance of PyPy. This test instance behaves the same as production and verifies that a package works correctly. The setup tools and setup.py file is the traditional method of uploading a package to PyPy. A new approach called Twine can simplify things. At the beginning of this section, Twine got installed in the virtual environment. Next, it can be used to upload the package to the test instance of PyPy. The following command uploads the tar.gz file and prompts for the username and password. Okay, so I need to change out the information that I used. Here, I need like my email address that I used. I guess I can do that. Okay, so that looks good to me. Interesting. Oh, let's try the twine. Oh, you know what? Oh, the repository URL. So that's going to be where's my repository URL? How do I create a new repository? Awesome, I did it. Oh, I have an invalid URL. Oh, okay. Yeah, let's use, okay, sweet, it gives me the URL that I need to use. God damn it, that's the URL they told me to use. How do I... URL. Nothing. URL. Download URL? Okay. Do I have to, is it GitHub? I thought the URL would be like a test.py URL. What URL do they want? Oh well, let's keep reading. Hopefully it will explain that. I doubt it will, but let's keep reading. Oh, that's the URL I used. I used that URL. What the heck? Yeah, that's the same URL I have. To test out whether the package made it, we can try and install it with pip. Didn't make it. Oh, I didn't include the... Requirement already says, but oh, okay, yeah, it looks like it did make it. I thought I would see it like up here in my project. No. The command looks like it has a space in the PyPy URL, but the index URL ends in // and hello-world is another argument that indicates the name of the Python package to be installed. For an actual production increase, an account would need to exist or be created. The same steps that are taken to upload to the test instance, including the validation, would also work for the real PyPy. Older Python packaging guides may reference those two commands. These may still work and are part of the setup tools set of utilities to package and upload projects to a package index. However, Twine offers secure authentication over HTTPS and allows signing with GPG. Twine works regardless if Python setup.py upload doesn't. And finally, it provides a way to test a package before uploading to the index. A final item to point out is that it may be helpful to create a makefile and put a make command in it that automatically deploys your project and builds the documentation for you. Here is an example of how that could work. So deploy -pypi. I'm not sure. Okay. Yeah, so this is an example if you had a makefile. Well, okay, I'm not sure how to. I've used makefiles before, and I've had an awful time with them. To be honest, makefiles are. And I don't. Well, I don't know. I need a better example to look into that. So let's just move on. Housing an internal package index. In some situations, it might be preferable to host an internal PyPy. A company where Alfredo used to work had private libraries that were not supposed to be public at all. So it was a requirement to host an instance of PyPy. Hosting have its caveats though. All dependencies and versions of those dependencies have to exist in the instance, otherwise installs can fail. An installer can't fetch dependencies from different sources at the same time. On more than one... Oh, so what they're saying is if you have your own instance of PyPy, even though there are packages that are available at other instances, your own instance have to have those packages because you can't just pick and choose which instances of PyPy to install packages from. You can only install them from one instance. So you got to make sure to have enough space on your instance to house the other packages on the public systems. So you got to design your repo to make sure it has enough space, and it's yeah. All dependencies and versions of those dependencies have to exist in the instance, otherwise installs can fail. An installer can't fetch dependencies from different sources at the same time. On more than one occasion, a new version had a missing component, so that package had to be uploaded for the install to complete correctly. If package A is hosted internally and has requirements on packages B and C, all three need to exist, along with their required versions, in the same instance. An internal PyPy makes installations go faster and can keep packages private, and at its core isn't challenging to accomplish. Note, a highly recommended full-featured tool for hosting an internal PyPy is DevPy. It has features like mirroring, staging, replication, and Jenkins integration. The project documentation has great examples and detailed information. Okay, I'm gonna bookmark this because if I ever need to house an internal PyPy, I'll be looking into that more closely. Right now, I'm just gonna keep moving. First, create a new directory called PyPy so that you can create a proper structure for hosting packages. Then create a subdirectory with the name of our example package. Okay, so let's do that. So we're going to create a new directory. Let's deactivate this virtual environment. I'm going to go up here. Okay, then we'll make a subdirectory. Okay, and we'll move into that subdirectory. The names of subdirectories are the names of the packages themselves. Oops, and I'll move up my bookmark. Oh, it gave us the command. Oops, I'll add a bookmark here and remove it from there. There we go. Okay, this is what I did though, so that's fine. I'm not sure what the -p means, but I will do a tree. There we go. Oh! There you go, perfect. Now copy the tar.gz file into the hello world directory. The final version of this directory structure should look like this. Okay, so the tar.gz, that's in the hello world directory. Under dist, there it is. So let's copy it, and we're going to copy it into PyPy. Hello world. There we go. All right, let's do a tree on PyPy. There we go. The next step is to create a web server with auto indexing enabled. Python comes with a built-in web server that is good enough to try this out. And it even has the auto indexing enabled by default. Change directories to the PyPy directory containing the hello world package and start the built-in web server. Okay, I definitely want to highlight this because the built-in web server is like really useful, and I barely use it. I never use it. In a new terminal session, create a temporary virtual environment and try out installing the hello world package from the local PyPy instance. So we're going to stop this. We're going to open a screen, and then we're going to move over to not sure what directory they want us to be on when we start the server. Oh, the PyPy directory. Okay, that's the one I'm in. In a new, okay, so now we'll try activate it, and finally, so in a new terminal section, create a temporary virtual environment to try out installing the Hello World package from the local PyPy instance. Activate it, and finally try installing it by pointing pip to the custom local URL. Okay, so we're giving it a absolute path, so it doesn't matter where I am in the... There we go. Oops, we got no module. Oh, BNB, I missed an argument. There we go. Source. God damn it. Oh, you know what? I didn't pass it the other arguments. It's confusing because it was on another line. Okay, now we're locking in indexes. We're collecting Hello World. That's going to come next. Oh, we got a connection refused. So there's like a firewall. Oh, you know what? I used the wrong port. I left off a 0. I don't have that port open. I'm running the server on port 8000, so if I try it on 800, it refuses the connection because it is not accepting anything to that port. Okay, but now we've got collecting Hello World, just like they have it here. Okay. In the session where the http.server module is running, there should be some logs demonstrating all the requests in the installer made to retrieve the Hello World package. So there should be some logs. I don't see the logs. Oh, you know what? It's going to be on the other screen. There we go. Yeah, now I see the logs. A production environment needs a better performing web server. The http.server module used in this example is used in this example for simplicity, but it isn't meant to handle simultaneous multiple requests or scaling out. Tip: when building a local index without a tool like DevPy, there is a defined specification that includes descriptions of normalized names for a directory structure. The specification can be found in pip 503. Okay, I'm gonna highlight this because I want to follow this if I ever need to make a local index and I don't have DevPy. All right, next section is Debian packaging. If targeting Debian or a Debian-based distribution such as Ubuntu for distributing a project, additional files are required. Okay, so this is going to work for Ubuntu as well. Understanding what those files are and how the Debian packaging tools use them improves the process of producing an installable .deb package and troubleshooting issues. Some of these plain text files require a very strict formatting, and if the format is even slightly incorrect, the package cannot install. Note, this section assumes the packaging is in a Debian or Debian-based distro, so that it is easier to install and use the required packaging tools. Package files. Debian packaging needs a Debian directory with a few files in it. To narrow the scope of what is needed to produce a package, most of the available options are skipped, such as running a test suite before completing a build or declaring multiple Python versions. Create the Debian directory where all required files exist. In the end, the Hello World project structure should look like this. All right, so let's make some new. Okay, so I think I can stop running this, and now I can kill my screen. And now we're going to be building out the Hello World. So let's do a tree, Hello World, and you can see I'm missing. Oh, did they want me to delete something from it? Wait, which, what did they want me to do? What's the main options? Create a Debian directory where all the required files exist. What are the required files? I don't know what required files they want me to create. It looks like they just want a Debian directory here. If I change to Hello World and I do Debian, I think that's what they want. But it looks like they took out some of these other ones. And I'm not sure what they put in the Debian directory. Note that the directory includes the setup.py and readme file from the native Python packaging section. Okay, perfect. That's what they want in there, so I will oblige. Okay. Oh. But then they don't have theirs right, because if that's the case, it should be, see how this Hello World has these two in it? That should be true for Debian. So if that's what they want, their structure isn't right. They've got a typo in their book. Okay, well, I guess I'm going to go with what this note says instead of what this is showing, and we'll see if it works or not. The changelog file. This file can be complicated to get right if done by hand. The errors produced when this file is not formatted correctly are not easy to debug. Most Debian packaging workflows rely on the DCH tool to enhance debugability. I've ignored my advice before and have tried to manually create this file. In the end, I wasted time because error reporting is not very good and spotting issues is very difficult. Below is an example of an entry in the changelog file that caused the problem. So let's try to see what kind of problem this might have caused. I don't see it. The entry produced the following error. Start of entry where expected. Can you spot the fix? Oh, I see it. You need a space between these two. Yep. And I accidentally snuck ahead and saw, but that's okay because I wouldn't have known that if I hadn't seen that. Oops, I don't know what's happening. I think I accidentally moved my wheel, so this is why I always have bookmarks when I move, because I have no idea where I was. Okay, yep, so we can see the fix. We need a space between the hashes and the username there. Well, it's not the username, but the name of the user. The username is here. A space between the hashes and my name was the cause. Was the cause? Oh, no, a space wasn't the cause. A space missing was the cause. A space was the solution. Okay, this book is starting to get bad. I wonder if now that I'm 31% of the way in, they just don't expect people to read the whole thing and are kind of getting lazy. Save yourself the heartache and use DCH. The tool is part of the devscripts package. Sudo apt-get install devscripts. Alright, so let's get the devscripts package. Okay, I'm going to highlight that as well. Oh, I don't need sudo on this. I've already got it. I'm logged in as root. Okay, there we go. Yes. The DCH command line tool has many options, and it is useful to go through its documentation. The main page is comprehensive. We are going to run it to create the changelog for the first time. This requires the one-time use of the -- create flag. Before running it, export your full name and email so that they get into the generated file. Export Debian mail equals that. Export Deb full name equals that. Now run DCH to produce the changelog. There we go. The newly created file should look similar to this. So I don't have the file yet because I am still installing devscripts, which has DCH in it. So the next step will be exporting full name and email. I'll just use what they have in the book so that the answer looks the same. And then we'll be creating a changelog automatically where we don't need to worry about little details in the syntax. It'll take care of that for us. Oh my god. Okay, so we'll move on. Export Debian mail equals fredo@example.com. Export full name equals Fredo Diza. Okay, so now run DCH to produce the changelog. DCH package hello world create -b 0.0.1 -d stable new upstream release. You notice I left out the backslash. That's just a character so that you can put the next part on a new line and still have it belong to the line above. I just kept it all on the new line because the word wrapped over. Okay, this newly created file should look similar to this. So, I don't know where I created the file. Where did I don't know where the file is. Yeah, I don't see it. I don't see the file. Let's grep for this. Try to find it. We gotta do a -r to look for folders. I don't have that file. I don't know where it was made. I don't think it was made. The Debian changelog is specific to Debian packaging. It is fine to have a separate changelog for the project when the format doesn't fit or if other information needs updating. Lots of projects keep the Debian changelog file as a separate Debian-only file. Oh, okay. You know what? I gotta check on something. I might. You know what? Because I've got to check on something, I'm gonna stop the video here. I've made it through a lot. So when we come back, we're going to be learning about the control file.